Welcome to Spotlight on Lakewood. I'm Mayor Bob Murphy. This month, we'll visit with some students up at Warren Tech who are involved in the NASA HUNCH program. Then we'll go over to the Blue Sky Cafe and cook up some pancakes. Finally, we'll learn what the city is doing to honor leaders in our community in the field of sustainability. Stay with us. I'm here at Warren Tech visiting with science instructional specialist Dan Snare, as well as some students later on, to learn about something called the NASA, yes NASA, HUNCH program. Dan, thanks for having us up here this morning.
Thank you very much. Welcome to Warren Tech.
First of all, HUNCH. What's the NASA HUNCH program? What's it all about?
It's a large acronym and it stands for High School Students United with NASA to Create Hardware. And it was a program that started about 8 years ago when a NASA engineer was at a barbecue and some high school students had built a barbecue. And the engineer saw that work and said, you know what, these kids are good enough to build stuff for NASA.
Really?
And that was down in Houston. And he went back to work later on and said, you know, we can get high schools to start building stuff for NASA.
So how does a student sign up? How do they participate?
You can go to the nasahunch.com website, and there's if you get a sponsor teacher and a project and you make a proposal, you can get involved. And if NASA HUNCH picks up that project proposal and they like it, then you can join the party.
How many students participate? There's obviously a group behind us here, but
yeah.
How many are here at Warren Tech, first of all?
We have about 40 students involved in HUNCH here at Warren Tech, and there's another 20 or so at Lakewood High School. And Lakewood and Warren Tech are in partnership. And so our HUNCH program is sort of an umbrella project that has several aspects, and we have about 60 kids.
So it sounds like there's some real out-of-the-box ideas and projects, examples of one or two of those maybe?
Sure. One of the projects we'll hear about a little bit later is to crack an egg in zero gravity and to fry it.
Trying to figure out how to get our astronauts eggs over easy in space, yes. up in the space station. That's a project after my own heart, being somebody from the food business. I like that.
Sure.
How long have you been doing this at Warren Tech?
We're at about 4.5 years now.
Okay.
Yeah.
Obviously, they are very, very engaged. You know, talk about maybe that level of engagement versus, I'll say history because I was a history major, sure. But you know, a typical, more of a textbook learning environment.
There's several levels of engagement. One is just to be involved in the space program, to have some connection with NASA astronauts, to know that your thing that you're working on could be up on the International Space Station at some point.
Yeah.
The other thing that engages people is real hands-on, authentic work. You know, when somebody asks you to read the chapter and answer the questions at the end, maybe that's not so exciting. But if you want to build some part that's going to be on the space station, that's engaging.
Yeah, that sure is.
And then also just the idea of having a project. A lot of our programs here at Warren Tech are project-based. The kid gets an assignment. Oftentimes they get to define the parameters of that assignment, and they get to work on it with their own passion, rather than being told you have to read through all these chapters and answer the questions. They get to design their own project. And
there's really a chance that their final product might be used in outer space, yes. By NASA. Isn't that something?
Yeah, yeah.
It must be an unbelievable level of excitement just with that possibility in mind. Yeah. Well, I'd like to learn more about it. As a chance to visit with some of the teachers and some of the students,
yes.
And look at the specific projects.
Yes, we
Great.
Can do that.
Let's go do it. We're here with two HUNCH students, Amanda SCHWARTZ and Ben Lontine. Thanks for hosting us today. We're up at Warren Tech, but you guys go to other high schools during the day. Amanda, what school do you go to?
I go to Arvada West.
And what grade are you in?
I'm in 12th.
You're a senior? Ben?
I go to Bear Creek High School, and I'm also a senior.
So let me ask you both how you feel about potentially helping out with the NASA space program. That must be fun, huh? Amanda?
It is really fun. It's fun to say to people, you know, that you're working for NASA and you get to design something that could be on the National Space Station.
Yeah. Does it give you some ideas of what kind of careers you might want to pursue?
Yeah, like engineering field, and like Amanda said, I'm thinking about going to Red Rocks first, and then maybe going to School of Mines, hopefully.
Well, we keep talking about the International Space Station and NASA and building projects that might be used in outer space. Now you guys don't know this, I have a career in the food business, and I'm sitting here with a lot of eggs in front of me, and that makes me hungry, number one, but also makes me curious. So what's up with the eggs? Tell us what you're up to with this project.
Well, we are designing a device that can crack an egg in 0G and then transfer it into a tray that then the morning class is designing something that can cook it in space. And there's like a lot of restrictions that come along with that just because of the particles that could get broken, and you have to keep it contained and you can't have open blades, and so it's quite a project.
Many people might not realize that cracking an egg in space is easier said than done. Why is there a need for this, Ben?
Well, just here on Earth, you can just take an egg, hit it against something, split it open, egg falls out. Yep. But if you were to do that in space, get an egg, hit it against something, the egg is going to stay in one part of the shell or the other because of the membrane that surrounds the egg and holds it and keeps it attached to the egg while it's inside of it. In an attempt to try to get it out of the egg, you need to apply a little bit of force to get it out of the egg, or else it's just gonna stay in there and it's not gonna do anything. So what this device is intended to do, you put an egg in this area right here, and then this pushes down on the egg and pushes it towards these two blades right here. And then as it's pushing down, it tears the egg apart, and then it goes into this dish right here.
Wow.
Which we put right there. Okay. So what this is going to do, this will push the egg towards these blades, and as it's pushing the egg toward the blades, these arms will move apart and it'll crack the egg, tear it in half. Okay. So
and then somebody else is working on a way to actually cook that egg.
Yeah. Yeah.
Well, this is fun. Looks like you're making real progress. Amanda, what's the biggest thrill about this whole program for you?
Well, this project in particular is awesome to me because this is like a prototype, and like a class in the future could take it further, and eventually we could see this up, in the ISS, and you could say, I had a part in that, in designing that, and that creature comfort that the astronauts will have of being able to say that they could cook an egg sunny side up in space, which right now they just have packets. So. Because
of work that you did here in 2012 on the Warren Tech campus in Lakewood, Colorado. That's really neat. Well, thank you both very much. This has been a lot of fun to learn about what you're up to, and best of luck in fine-tuning this machine, this apparatus, and I know you'll get it done.
It's a real trial and error process, but we'll get it done.
That's what great inventions, that's how they come forth. I'm here with another HUNCH program student, and as it turns out, neighbor of mine, LENA GIBBS. Thanks for having us up here today.
Yeah, thanks for coming.
Tell us what school you go to, Lena.
I go to Lakewood High School.
You go to Lakewood High School, right down the street from our neighborhood. What grade are you in?
I'm a senior.
You're a senior as well. Did you ever think that you'd ever have a chance to possibly see your work on the International Space Station someday if things went well?
Well, that's partly why I joined, because my friends were in it the year before I joined, and they talked about it, and I thought it sounded really cool, just the hands-on, and also that they're working with NASA, and I love space, and I've always been interested in NASA, and so just the idea of being involved with it, and I wanted to be an astronaut, just really intrigued me.
Well, you're working on something very specific here, I can tell. Tell us about it.
Well, we started off, NASA came to us with the HUNCH program and asked us to create a personal plant chamber to go up on the International Space Station. So we started off doing this design, which in zero gravity, when you put water on the roots, the water will just stay on the roots because there's no gravity to pull it off. So on the International Space Station, there's tons of root rot and all the plant testings that they have up there. So we designed, there's a water chamber down below here, and then we would mist water up onto the roots with nutrients. So then the plant's roots are hanging down in this chamber in here. And then we would, with pressurized air, push the water back out, and then with whatever water was left on the roots, we would spin it using a motor, creating kind of a gravity, and it would wick it off of the roots and then get pushed into the chamber with the rest of the water. And so we went down and tested that, and it worked really well.
When you say you went down?
We went down to
Houston?
Yeah.
Really?
And we flew that one on the zero gravity flight.
Mm-hmm.
And it worked really well. But then because of the shuttle program stopping, we are now don't have our own. And so it's more money to send tests up. So our size was reduced originally to this size, which is a 10 by 10 by 10 centimeter cube. But they told us then after a little bit that we could actually do 10 by 10 by 15. So we had to smush all that into a smaller area.
It's a scientific term, smush.
Smush.
Right? Yeah.
Yes.
Does it give you inspiration to pursue a certain career path?
If I'm not sure what I want to do right now, but if I did, I would definitely want to do some sort of engineering, like aerospace, or just working on this, work for NASA in some way.
I'm here at the machine shop at Warren Tech with two more HUNCH students, ANDI Champion and Adam Rep, and you guys are working on a really exciting potential project for NASA. But first, tell us a little bit about yourselves. ANDI, what school do you go to?
I go to Chatfield High School.
You go to Chatfield? And what grade are you in?
I'm a junior this year.
You're a junior. Adam, what school do you go to?
I'm actually enrolled in Jeffco Virtual this year.
Tell us what you got going here. Some sort of a way to wash clothes in space? Wow.
It's
fascinating. Tell us about it.
It's all got to fit in this little box here, which is a very small space. I mean, just looking at it, it's about 20 inches by about 17 by 9, which is a relatively small space to get anything in. And then you factor in the zero gravity part, which is
an extra challenge.
That complicates things a little bit, doesn't it?
Sir, people take that for granted down here.
But what we basically did is our design has about 3 sections. That one section has a piston that you put the t-shirt or the fabric in, and then it goes up and down with the water in it, and then it filters the water through a filtering system with a hydraulic pump, and that cleans the water so that they can reuse it since they have limited water supply.
Did you guys have parameters, have sizes sort of dictated to you from NASA, how big it could be, how small it could be?
This box right
This box,
here.
exactly.
Okay, okay.
This is it.
We're waiting for the materials so that we can get it put together and then hopefully trial and error, figure out what works, what doesn't, and then test it.
How many students in all are working on this particular project? Two. Two.
Yes, sir.
Tell me how exciting it is. Either or both of you can answer this. Just the possibility that something you're working on here at Warren Tech in Lakewood, Colorado might actually be used by astronauts in space someday.
I'm ecstatic, honestly, just because when I was little, I always thought about hopefully when I grew up, I'd figure out, solve some problems with whatever and invent something, but I always thought that it would be after high school, after I've been seasoned and well experienced, but getting to do it at 16 when I'm only a junior in high school, it's pretty incredible getting to know that I get to make a difference and get outside of my own world.
Well, good. I'm excited for both of you. I would like to be able to come back and kind of get an update on the status of the project and see how you guys are doing.
Yes, sir. Please do.
You're always welcome.
Thank you very much
Thank you.
both of you. Dan, we just had a chance to visit with Andy and Adam about the clothes washer they're trying to design for the International Space Station, but we've got 2 different boxes here. Tell us about the difference between them.
Sure. NASA has relied on private suppliers or such as Boeing and Lockheed Martin to build a lot of their equipment. And years ago, they made a transition in some of their equipment that high school students could build some of this stuff for a lot cheaper. So it's saving taxpayer dollars, and it's giving high school students the opportunity to build things that are highly technical, and NASA needs them. Boeing charges quite a bit to build a box, and they have a lot of contracts that allows them to charge that. They have a high overhead, and it's indeed high quality. NASA provides us with the raw materials, and we're not limited by things like wages. Our students do this for free. NASA provides the hardware, and therein lies a huge savings. The raw materials that go into this box, about $1,800.
So $1,800, how much for the commercially produced box?
40 to 50 to 60,000.
1,800 versus 40 to 60,000. Yeah.
Yeah.
not just educating our students, but saving a lot of taxpayer dollars in
Yes.
the process. Dan, this has been incredibly exciting for us to come up here. Us, I mean the whole film crew. I'm not sure that we all knew all the really neat things that you're doing at Warren Tech with this HUNCH program, and we can't wait to hear about your projects at work up there in the International Space Station.
Well, thank you very much. You're welcome to come back anytime.
Thank you. Stay with us as we head over to the Blue Sky Cafe for great natural food and some yoga.